Many of its plastic parts have been labeled for the day they can be recycled. It's painted with a new technology that reduces factory emissions. And its air conditioning refrigerant won't deplete the ozone. No matter which color neon you choose, we've done our darndest to make it green. Say hello to neon. $89.75 for starters, $12.5 nicely loaded.
Look familiar? You may have seen this recent neon advertisement, a great example of the way the Chrysler Corporation is telling its customers about environmentally friendly improvements on its vehicles. One improvement is the use of R134a refrigerant in the air conditioning systems of new vehicles. Hi, and welcome to this month's MasterTech. In the past few years, you've heard a lot of discussion about R134a, the automotive hydrofluorocarbon that won't deplete the ozone layer. This month on MasterTech, we're going to expand on the topic of R134a by discussing leak detection, refrigerant analysis, and service procedures for the adaptation of some late model R12 systems to R134a refrigerant. But before we get started, there are a few important precautions you should be aware of when using R134a. First, it's important never to use R12 refrigerant in an R134a system, as component damage and system failure may occur. Only Chrysler and SAE-approved service equipment should be used for recovering and recycling of R134a and R12. Also, avoid breathing R134a mist or vapor. Although R134a refrigerant is no more hazardous than R12, exposure to R134a may cause eye, nose, and throat irritation. So be sure your workstation is well ventilated. And never pressure test or leak test R134a systems using compressed air. Some mixtures of air and R134a may be combustible and potentially dangerous under high pressure. Finally, remember the only approved automotive refrigerants are R12 and R134a. Refrigerant substitutes such as Freezone, R176, GHG12, OZ12, and HC2A, just to name a few, should not be used. Despite manufacturers' claims, some of these refrigerants have been found to contain flammable levels of hydrocarbons. In addition, these products may be caustic and may cause personal injury or damage to R134a systems. If you need to review any information regarding R134a systems or service procedures, check out the April 1992 Videotech or the October 1992 MasterTech. Now let's get going with R134a leak detection procedures. When a vehicle's air conditioning system is not cooling properly, leaks in the system are one possible cause. When a leak is suspected, first you'll need to determine if the system is properly charged using a manifold gauge set, a thermocouple, and the charge determination graph in your service manual. On Concorde, Intrepid, Vision, LHS, and New Yorker vehicles, the DRB3 and the thermocouple may also be used to determine the amount of charge in the system. See the service manual of the vehicle you're working on for specific details. If the system is empty or has a low refrigerant charge, a leak is likely. With an R134a system, leaks may be more difficult to detect than in an R12 system because of the smaller molecular structure of R134a. Two types of leak detectors can be used for R134a. Electronic leak detectors, specially designed for R134a, and a recently approved R134a leak detection dye. Electronic leak detection is the preferred method. However, there may be certain situations where the dye method is necessary. When using the electronic leak detection method, your first step should be to visually inspect fittings, lines, and components for an oily residue to help determine the possible location of the leak. Next, if the system contains any refrigerant, position the vehicle in a work area that is as free from wind as possible. If you have previously determined that the system is empty and will not hold a charge, evacuate the system to the lowest degree possible. Then charge the system with 10 ounces of refrigerant before placing the vehicle in the work area. Next, bring the system up to operating temperature and pressure. The steps used to reach operating conditions vary between vehicles. For the 1995 Neon, run the engine for 5 minutes with the windows open, the transmission in park, and AC controls set to outside air, full cool, with the blower on high in AC mode. Check the manual of the vehicle you're servicing for details. Then use an R134a electronic leak detector to look for leaks. Several different models are approved by Chrysler and SAE. Leak detection must be done on the vehicle with the engine off. TSB 241394 and the manufacturer both provide operating instructions for using electronic leak detectors. Run the leak detection probe around the system in a continuous path. Move the probe slowly and stay within 1/4 inch of the surface. The slower you move the probe, the more likely you are to find small leaks. Try to stay close to the bottom surface of lines and fittings, since R134a is heavier than air and will tend to stay low. Also, be careful not to contaminate the leak detector probe by touching underhood components. If the part being tested is particularly dirty, it should be wiped clean with a shop rag. Do not use any cleaners or solvents on parts to be tested, since the leak detector may be sensitive to their ingredients. When a leak is detected, do not stop at that point. Note the location, then continue testing the rest of the system to check for other possible leaks. Then any leaks should be verified by blowing shop air in the suspected area and rechecking the component. To leak test the evaporator core while it is still in the AC module, turn the AC on and the blower on high for at least 15 seconds. Then shut the blower off and wait at least 2 minutes for refrigerant to accumulate. Insert the leak detection probe into the recirculating door opening or the heat duct near the evaporator. If a leak is present, the detector will sound. In addition to electronic leak detectors, a leak detection die sold through professional service equipment, especially for R134a, can be used to find AC system leaks. It is recommended that the die method be used on vehicles where a very small leak is suspected, but its location cannot be found using an electronic leak detector. With this type of leak, a vehicle may take several days to a week to lose a significant amount of refrigerant. Before adding the die to the system, read the labels and precautions included with the die. Then add 1/4 ounce, the contents of 1 die bottle, to the low pressure port using an AC system die injector, available through PSE. If the AC system is empty, evacuate the system for 30 minutes at 26 inches of mercury or greater. Then recharge the system, adding the 1/4 ounce of dye with the charge. Once the dye has been injected, operate the AC system to allow the dye to mix with the compressor oil and circulate through the system. The amount of time you should run the compressor depends on the size of the leak. A very small leak may take several hours or even days of AC operation to appear. Check for leaks using a black light. Run the light along all components, lines, and fittings. A bright yellow-green glow from the dye will indicate the location of the leak. To check some difficult-to-reach locations, it may be easiest to use a mirror. Or you can wipe the suspected leak area using a clean cloth. Then check the cloth for dye, indicating a leak. Once you find the leak and repair the problem, any fluorescent dye on external surfaces should be removed using a dye remover. Then apply a dye identification sticker in a prominent location on the vehicle. This will indicate to other technicians that dye has already been introduced into the system and that there is no need to add dye for future leak testing. And finally, remember, After repairing a refrigerant system leak, you should verify that the condition was corrected by leak testing the area of the repair and the service ports. In our next section, we're going to take a look at refrigerant analysis. But first, try your hand at this review question. The preferred procedure for leak detecting R134a systems uses A, an electronic leak detector, B, leak detection dye, or C, both A and B. The answer is A. The Chrysler Corporation preferred method of leak detection for R134a vehicles is an electronic leak detector. Have you ever been in a situation where it was necessary to recover or charge a vehicle's AC system, but for whatever reason you could not identify the type of refrigerant in the system? Well, now there's a simple way to analyze the type and percentage of refrigerant in a vehicle or a container using the Neutronics Automotive Refrigerant Identifier. Use of this unit could save you from potential cross-contamination of refrigerants and damage to your recovery recycling machine. In addition, the identifier will visually and audibly alert you to the possible presence of flammable refrigerants in the system. The refrigerant identifier is available through PSE and is very easy to use. Begin by making sure the vehicle engine is off. When you plug the unit into a power outlet, the unit will display the word cold. It will stay in this mode until the unit is ready to receive the sample. The identifier will then go into a self-calibration mode and purge itself of the remains of previous samples. The word cal will appear on the display. After purging and self-calibration, the sample light will glow and hose will appear on the display. Next, choose either the R134a hose or the R12 hose, depending on the type of vehicle you're working on. A separate adapter is also included for analyzing canister contents. Inspect the ends of the hose and the inlet port on the unit to make sure they are clear of obstructions. Connect one end of the hose to the inlet port on the unit. Then connect the other end of the hose to the AC vapor port. Never test from a liquid port. Next, press the Enter button. This will allow a sample of the gas in the system to pass into the analyzer. During this time, the sample light will be illuminated. When enough refrigerant has entered the system for proper analysis, the unit will automatically show the refrigerant percentages on the display. The R134a or R12 light will illuminate if the sample is at least 98% pure. If the sample is an unacceptable mixture, less than 98% pure of R134a or R12, or has R22 or hydrocarbons in it, the fail light will illuminate, and the unit will display the percent by weight of each refrigerant. Any time a fail reading occurs because of a mixture of refrigerants, you will need to recover the system using a separate canister. Do not use an R12 or R134a recovery recycling machine when an unacceptable mixture of refrigerants is present. In addition, if any flammable refrigerant is present in the sample, fail will be displayed. An audible warning will sound and a warning light will illuminate. To check another vehicle, you'll need to disconnect the hose from the unit. Then press the Enter button, and the unit will self-calibrate and purge itself of any remains of the previous sample. Further instructions for use of the Neutronics Refrigerant Identifier are included with the unit. Contact PSE for price or order information. Well, that gives you a good idea of how refrigerant analysis works. Now let's see how closely you were paying attention. Before the unit is purged, the sample hose should only be connected to A, the input port of the analyzer, B, the vapor port of the vehicle, or C, neither the analyzer nor the vehicle. The answer is C. When the unit is powered up, it will automatically self-calibrate and purge. No hoses should be connected at this time. So far, we've looked at R134a leak detection methods and refrigerant analysis. Now let's change direction a bit and look at how to adapt current R12 vehicles to use R134a. You'll find all the information we discuss in this section on TSB 240195. Be sure to have this TSB handy before beginning any adaptation procedures. It's important to note that the procedure on this TSB should only be performed on vehicles to maintain air conditioning operation when R12 refrigerant is no longer available. Cooling performance may be less than the original system, depending on operating conditions, and may also vary between models. When it is necessary to perform these procedures, your first steps will be to find out as much past service information as possible and gather all the necessary parts. The parts are listed on the adaptation component chart found at the back of the TSB. For our adaptation, we'll be using a 1992 2.5-liter minivan. So by looking on the component chart for this vehicle, we can find all the parts we need. Next, you'll need to determine if the system is working properly. If it isn't, diagnose the system and identify any leaks or malfunctioning components. In this case, the AC system is functioning properly. So our next step is to operate the system at engine idle speed, on high blower, and outside air for 15 minutes to maximize oil accumulation in the compressor. Then recover the system using an approved R12 recovery recycling machine. Once the refrigerant has been recovered, you should repair or replace any failed components as necessary, except the compressor, since you may be replacing it anyway for the adaptation. During service, if you disturb the seals at AC connections, you'll need to replace them using R134a compatible seals or O-rings. Be sure to lubricate the seals with the appropriate PAG oil type found on the component chart. However, when joints are left undisturbed, their seals do not need to be replaced, since the small area exposed to refrigerant has been sufficiently sealed with the mineral oil from the R12 system. Next, remove the compressor. In this case, we'll be reusing this compressor for our adaptation, so we need to drain the mineral oil once it is off the vehicle. When a new compressor is required as part of the adaptation, drain the mineral oil from the new compressor. And just a reminder, when a new compressor is to be used for the adaptation, be sure to first look at the compressor on the vehicle to see if it may have been replaced previously. If a Sandon compressor was installed on the vehicle as part of a previous repair, it will not have to be replaced at this time, unless it has failed. The Sandon compressor can be identified by the casting numbers 709CC or 709CA, adjacent to the suction and discharge ports. Next, look at the adaptation component chart at the back of the TSB and find the type and amount of R134a refrigerant PAG oil needed. With the compressor off the vehicle, add the specified type and amount of oil to the compressor that is to be used for the adaptation. We'll add 6 ounces of the PAG oil specified in the chart to the compressor we removed from the minivan. Now the filter dryer can be removed from the vehicle and discarded. Next, you'll need to replace the high-pressure relief valve with the one listed on the adaptation component chart. The high-pressure relief valve may be found in one of several places, depending on the type of vehicle and the type of compressor on the vehicle. On our 92 2.5-liter minivan, the high-pressure relief valve is on the compressor manifold. On some vehicles, you'll need to install the new high-pressure relief valve on the compressor itself. On others, you'll need to take the high-pressure relief valve from the new filter dryer and replace it with an updated one. Still other vehicles will include the correct high-pressure relief valve as an integral part of the new filter dryer and will not need to be replaced. With this variation, the component chart will state included on dryer in the appropriate column. And finally, on a very few vehicles, the new high-pressure relief valve will be installed on the high side line. Like the high-pressure relief valve, installation or replacement of the high-pressure cutout switch also has several variations. On vehicles such as the one we're working on, where a high-pressure cutout switch is already present, you'll simply need to replace it with a new one. On other vehicles, a high-pressure cutout switch must be installed on an appropriate charge port adapter T. We'll discuss proper installation of the charge port adapters in a few minutes. In addition, one or both wiring overlays will be used in the adaptation. To install the wiring overlay, first connect the wiring connector to the switch. Now connect one side of the Y wiring harness to the compressor clutch connector. The other side will be connected to the engine wiring harness connector when the compressor is back on the vehicle. Cut the wires on the Y harness to the appropriate length and splice it to the high-pressure cutout connector wiring. Some vehicles may only use one wiring overlay. Refer to the TSB for a description of how the wiring overlays are used. On Jeep vehicles, the procedure is to remove the low-pressure cutout switch along with the Schrader valve core, if present, from the new filter dryer. Install the threaded adapter on the filter dryer and the new dual-function high-pressure, low-pressure cutout switch to the adapter. Then splice the new cutout switch connector to the harness in place of the old connector. The new connector will be connected to the dual-function switch once the filter dryer and compressor are on the vehicle. And speaking of the filter dryer installation, this is our next step. Also, install the compressor at this point. When installing these components, be sure to use new R134a compatible seals. In addition, when a new compressor is required for the adaptation, a new drive belt must also be installed due to a change in belt length. Check the compressor drive belt chart included in the TSB for the correct part numbers. Next, we're going to install new R134a charge port adapters. As mentioned previously, a T adapter and high-pressure cutout switch may need to be installed earlier in the procedure, depending on which vehicle you're working on. But pay attention now while we discuss proper adapter installation. Before installing adapters, you'll need to clean the old R12 charge ports with a metal brush. Then select suitable adapters using the adaptation component chart. In many cases, more than one type of adapter can be used. You should choose one that allows for sufficient clearance to attach R134a service equipment couplings and the high-pressure cutout switch if necessary. Also be sure to check for clearance between the adapter and hood of the vehicle. In addition, it's important to note that if a 90-degree elbow adapter or T adapter is selected, as when installing a new high-pressure cutout switch, you must also remove the Schrader valve core from the charge port. If the Schrader valve core is not removed, the system cannot be evacuated or filled with refrigerant, and the high-pressure cutout switch, previously installed on the T adapter, will not work. Use straight adapters whenever possible, since these do not require Schrader valve core removal. Any remaining R12 ports on the system should be capped off using seal caps, part number 477-3153 or 477-3154. Then evacuate the system for a minimum of 45 minutes. When the system evacuation is complete, charge the system with R134a using the amount specified on the adaptation component chart. Through the sight glass, the refrigerant may appear as a milky white stream due to a residual amount of mineral oil left in the system. The sight glass, however, should not be used on this or any adapted R134a system to determine the charge level. Well, there you have it. The system is now adapted from R12 to R134a. But before you send the vehicle back to its owner, there are two more steps for which you're responsible. First, you must completely fill out a light blue R134a adaptation label, including the refrigerant amount in pounds, the lubricant type, part number and amount, the name and address of your dealership, the dealership code, and the date the adaptation was performed. Then install the label in place of the existing R12 label and apply the clear Mylar overlay. Finally, check the system for proper performance. You can find performance test procedures in both the TSB and your service manual. Now, before we say goodbye, let's take a shot at one more review question. When a new compressor is used for the adaptation procedure, you should A. Drain the mineral oil from the old compressor, B. Drain the mineral oil from the new compressor, or C. Drain the mineral oil from both the old and new compressors. The answer is B. When a new compressor is used for the adaptation, you should drain the mineral oil from the new compressor, then refill it with the R134a compatible PAG oil. So I guess that covers it. This month, we've discussed leak detection, refrigerant analysis, and of course, R134a adaptation. 3 procedures you may be performing in the future. And speaking of the future, be sure to join us next month on MasterTech, when the topic will be 1996 minivan body electrical. We'll see you then.